Hi, friends. We're going to be getting started in just a moment. Welcome, everyone. We'll be right back. Welcome, and thank you so much for joining us for Ask Me, our educational webinar series. My name is Sheri Strahl, and I am the president and CEO of the ALS Network. And I want to thank our lead sponsor, Mitsubishi Tanabe Pharma America, as well as our mission benefactor families and everyone who helps support our programming. Programs like this one today, as well as the multitude of services we provide, would not be possible without these generous donations. Now, today we have many viewers who may be less familiar with ALS than our regular watchers are. So let me start by saying that brain health is everyone's issue. And ALS is a progressive neurodegenerative disease that impacts one's ability to walk, talk, move, and ultimately breathe. And it is predicted that the number of ALS cases will increase globally by 30 to 40% by 2040. And while around 10% of ALS is genetic, 90% is sporadic. And this means that ALS can happen to anyone, and it's on all of us to be a part of the solution. Now, the ALS Network offers a wide range of services free of charge to people with ALS and their families. So please know that if you need a piece of equipment loaned to you, emotional support or counseling, assistance with finding home care, help understanding insurance benefits, guidance in finding an ALS specialist for care or a clinical trial, or just someone with expertise to answer any other questions about ALS. Oh, give me one moment. Thank you so much. There we go. Any other questions about ALS? The ALS Network is here for you. We're providing high quality, personalized, and local services. We are your team in California and Hawaii, and we are glad to provide multi-layered support. So to learn more about the ALS Network and programs and services we provide, we invite you to visit alsnetwork.org for more information. And we are proud to collaborate with other impactful patient advocacy organizations across the nation through our membership in ALS United. So to find local care service outside of California or Hawaii, please go to alsunited.org. Now, in addition to care and advocacy, one of the ALS Network's key mission pillars is research. We fund and support highly innovative, peer-reviewed research designed to accelerate the search for effective prevention strategies, treatments, and cures for ALS. Now, as we continue to support cutting-edge research, initiatives like what you're going to learn about today from Neuralink represent a promising convergence of neuroscience and technology, and it is changing what it means to live with ALS. So let me quickly tell you about these important guests who are here with us tonight. You're going to meet Romina Nejad, who leads clinical trials at Neuralink. Now, she joined Neuralink in 2021 and played a key role in launching Neuralink's first in-human trials. Romina holds a master's degree in neuroscience from the University of Toronto, and brings a passion for advancing technologies that restore and expand human potential. You are also going to meet Brad Smith, who is a proud father, husband, and son who became the first clinical trial participant living with ALS to receive Neuralink's brain-computer interface implant in November 2024. With logistics expertise, Brad has scaled companies, led IPOs, and turned ideas into products, always figuring out how to get it done. After moving to Arizona to support a growing golf shoe company, he faced an ALS diagnosis and is tackling it with determination. Committed to innovation, Brad explored non-medical eye gaze devices, Synchron and Neuralink brain-computer interfaces, proactively sharing insights to better serve patients. And you're also going to meet Jake Schneider. Jake is 35 years old. He's from Austin, Texas, and he was diagnosed with ALS in 2022 and joined the Neuralink clinical trial, receiving his implant in 2025. Now, before his diagnosis, he worked as a surgical sales representative, representing a product for ablation of uterine fibroids to serve as an alternative to hysterectomy. I can't overstate how important that work is. He has a 6-year-old son, and he loves collecting Pokemon cards with him. You're also going to meet Nick Wray. Nick has been living with ALS for 3.5 years and thriving with Neuralink for about 3 months. He's a musician and a graphic designer, a philosopher and creator, living as authentically as he can. But first, ALS Network Senior Director of Research, Sarah Dougherty, will set the stage for us. Sarah holds a PhD in neuroscience and previously served as the program manager for the ALS research program at the Department of Defense's CDMRP. At the ALS Network, Dr. Dougherty oversees our expanding efforts to advance cutting-edge science through direct research funding and thought leadership. So Sarah, why don't you get us started?
There we go. Can everybody see me? Okay, I can see me. Thank you, Sheri. As Sheri just mentioned, at the ALS Network, our mission is to accelerate discovery and improve the lives of people living with ALS through bold, collaborative, and community-driven science. Our research program was built around a simple but powerful idea that innovation thrives when scientists, clinicians, engineers, and individuals with lived experience work together to solve problems that truly matter. The ALS Network Research Innovation Grant, our flagship initiative, is designed to fuel creative, high-impact ideas that can reshape how we understand, diagnose, and treat ALS. Through this program that's offered in partnership with ALS United, we aim to support projects that take intellectual risks, projects that may be too early for traditional funding, but hold the potential to transform patient outcomes and accelerate progress towards a world without ALS. In recent years, innovation in ALS research has expanded beyond traditional biological and pharmacological approaches. We are particularly excited to support emerging intersections between technology and neuroscience, from advanced data analytics and artificial intelligence to brain-computer interface interventions, such as those pioneered by Neuralink. These technologies are truly redefining what's possible for communication, mobility, and independence for people living with ALS, and they embody the kind of forward-thinking work that the ALS Network aims to champion. Brain-computer interface research, also known as BCI research, which we'll hear a lot about today, represents one of the most promising and transformative frontiers in ALS. As the disease progressively impacts mobility and speech, BCI technology offers a lifeline, restoring communication and autonomy by directly linking neural signals to external devices. Beyond improving quality of life, BCI trials also generate invaluable insights into neural circuitry, disease progression, and the resilience of the human brain. By integrating neuroscience, engineering, and clinical care, BCI research exemplifies the type of cross-disciplinary innovation that can both alleviate symptoms today and inform future therapeutic breakthroughs tomorrow. The ALS Network is inspired by the growing intersection of this neuroscience, data science, and engineering, an area where tools like BCI and other assistive technologies are opening doors for communication, independence, and quality of life. Supporting these kinds of innovations reflects our belief that progress in ALS will not come from one single discipline alone, but from collaboration across many. We aim to foster a vibrant community of researchers and innovators who share our commitment to turning discovery into hope and ultimately into cures. We are thrilled to present our Ask Me today and are so excited for all of you to hear what Neuralink has been up to. With that, I give you Neuralink's clinical trial lead, Romina Nejad.
All right. Thank you so much, Sheri and Sarah. We're very excited to be here today. Let me grab my slide deck. All right, so you already gave a very thorough introduction, so I won't spend too much time on that. But for those of you on the call, my name is Romina. I'm excited to talk about Neuralink today. I'll give a very brief overview and jump in so that three of our participants can share their experiences using the device and involved in the clinical trial. I do want to add a disclaimer that the devices that we're going to be speaking to you about today are investigational and they are not commercially available. So they're all under clinical studies that we're studying. They haven't been FDA approved, and the participant experiences that you're going to hear on today's call are theirs alone and theirs to share, and not necessarily endorsed by Neuralink. But with that, I'm really excited to dive right on in. So our mission at Neuralink is to create a generalized brain-computer interface to restore autonomy to those with unmet medical needs today and unlock human potential tomorrow. And, just to bring that in, like, what does that actually mean? Our goal here is to connect neural experiences that every human experiences with computers, with hardware output devices. So everything that we experience as humans, from movement to speech to vision, that's all encoded in our brain through brain cells called neurons. And our goal at Neuralink here is to develop the technology that can interface with those brain cells and translate that intention from the brain into a real world output. And in the way we're doing that is through the clinical trials that I'm going to dive into today. So our brain-computer interface technology stack consists of three different components. We have a fully implantable brain-computer interface. It's an implant with over 100, well, it has 128 very thin and flexible threads, as you can see in the left-hand side schematic there. You can see how, easily bendable and flexible each thread is. And within those 128 threads, we have over 1,000 channels. And these channels essentially get placed into your brain by a surgical robot called the R1 robot and a neurosurgeon under under anesthesia and a neurosurgical procedure. And once this implant is placed in the brain, it connects to an app, which we call the Link app, and then that app decodes your neural activity and translates that into something useful. And so in this example here, we're seeing a web grid game where the neural activity that's being decoded is movement intention. So thinking, you want to move a cursor up, down, click, drag, that kind of thing. And so the implant itself is decoding that brain activity and translating it into a digital output here, such as clicking those blue boxes that you see. We have other outputs that I'm also going to go into with the different clinical trials that we have. But first, before I dive into that, I just want to give an overview of our surgical robot. So as I mentioned, our implant threads are extremely thin and flexible. And so the most skilled neurosurgeon in the world can't physically manipulate those threads using their hands. So we have the R1 robot that essentially goes in and takes each one of those implant threads and places them into the brain. And we do this under the guise of neurosurgery, a neurosurgical procedure. You can see here, once the threads are inserted, that there's minimal disruption to the brain. You don't really see any bleeding or anything like that happening here. And it's all really through the development of our technology stack. So the R1 robot itself is very skilled at vessel avoidance. So as it's going into place, the electrodes into the brain, it's avoiding vessels. It's also coordinating with patient breathing patterns as well as brain motion. And so it's a very skilled robot that can insert these electrode threads with high precision and accuracy in a very short amount of time. Once the implant is implanted in the brain, what you're seeing here in the middle panel here is your neural activity. And so the electrodes are placed next to your neurons in a specific brain area. And that area depends on what the final output is going to be. Here we see that once that implant is implanted in the motor cortex, if we're talking about motor and decoding movement intention, you see all of that neural data is streaming from the implant. It's a wireless implant, so once it is actually embedded, implanted into the brain, you can't visibly see it. And so that neural data is wirelessly communicated from that implant to the BCI app, the Link app on your computer. And then that's where all of the decoding algorithms happen that translates that activity, that thought, that thinking intention into an output. So again, here you see device control demonstrated by WebGrid here. We have a number of different clinical research areas that we're focusing on. So we have device control under our studies in the United States, Canada, the UK, as well as the United Arab Emirates. We also have a speech restoration trial called our Voice trial that we recently launched in the United States. And both of these device control and speech restoration trials are actively enrolling. We also have coming down the pipeline a vision restoration trial. That's a slightly different device that we don't have approvals for yet and have not launched in clinical trials yet, but that's coming down the pipeline. And then through these number of studies, depending on the country and location that you're in, you can enroll, and there are different outputs that our participants will speak to later in this talk. So narrowing in on the devices and trials that we have available in the US, we do have 3 studies that are actively enrolling. The PRIME study, which will allow you to control digital devices such as your computer or phone, keyboard, just with your thoughts. We have a Convoy trial that would control physical devices such as an assistive robotic arm, a wheelchair, again, using your thoughts. And then we have the Voice trial, which would translate thought into speech or text. This is not speech restoration per se to give you back your ability to speak, but it is speech through computers. And so these 3 trials are actively enrolling individuals with ALS, spinal cord injury, irreversible speech impairment, as well as upper limb impairment, stroke, and a slew of other neurological conditions as well. And I just want to mention right now, these 3 trials are all investigational. They're early feasibility studies. So our primary objective is to demonstrate the initial safety of the robotic surgery and of the implants. And then our secondary objectives are to improve the product from human learning. So we're really looking for pioneers who want to give the most feedback to us as possible so that we can improve the devices as we move along that path to commercialization, so that they can help us develop the technology and advance the research so we can get to a point where our brain-computer interface is ready to be a commercially available product. And if you want to learn more about Neuralink clinical trials, you can go to neuralink.com/trials. We have an overview of every trial up on that page. You can also join our patient registry if you want to be within our registry. We contact and speak to individuals who are preliminary eligible for any of our trials through the registry. So if you are interested in any of these trials or future trials, or just want to stay in touch with Neuralink, you can join our patient registry and visit this link over here. And so with that, I'm going to transition into the participants. Brad has prepared this video that I'm going to share with you all today. And here we go.
Ladies and gentlemen, fellow warriors living with ALS, and the incredible caregivers who stand by our sides every day, thank you for being here. My name is Brad Smith, and I'm honored to speak with you today. You might know me as the 3rd person in the world to receive a Neuralink brain implant, the first with ALS, and the first who's nonverbal. I am also known as ALS Cyborg on X. I typed this speech using just my thoughts, straight from my brain to the computer. Isn't that wild? If you're like me, you've probably dreamed of a day when technology could give us back some of what ALS has taken. Well, I'm here to tell you that day is here, and it's getting brighter. Let me start by sharing a bit about my journey because I know many of you are walking a similar path. 7 years ago, ALS hit me like a bad driver in a Phoenix parking lot. It stole my ability to move, speak, and even type without exhausting effort. I relied on eye gaze technology, which was a lifeline but trapped me in dark rooms, away from the sun, and made communication feel like texting on a flip phone from 2002. Thoughts piled up in my head. Dad jokes, ideas, words for my wife Tiffany and our kids Lincoln, Edison, and Abigail. But getting them out was painfully slow. I felt stuck, like driving a car with a steering wheel made of jello. Then Neuralink entered the picture. I'd been following Elon Musk's companies for years, but after my diagnosis, Neuralink became my beacon of hope. When the patient registry opened, I jumped on it, lobbying shamelessly through their portal. In November 2024, at Barrow Neurological Institute in Phoenix, I became patient 3. The surgery was a breeze for me. I napped while the geniuses did their work. They implanted a device the size of a stack of quarters in my skull, with 64 threads and 1,024 electrodes in my motor cortex, listening to my brain signals. There were no real problems or pain from the surgery itself. It was straightforward. And the team at Barrow Neurological Institute is amazing. I had no fear of the surgery. Recovery had its rough moments, but not for any medical issues, synthetic narcotics, and I had a fling I don't recommend, knocking me out for a couple of days. I spent just 24 hours in the hospital for observation, and by day 3, I felt normal again. Staples came out after a week, and I was cleared to start training shortly after. No lingering pain, no complications, just excitement to get started. From what I've heard from other patients, this is typical. A short, manageable, painless recovery that gets you back to life faster than you'd expect. Now let's talk about what Neuralink actually is, because understanding it is key to seeing its potential for all of us. Neuralink is a brain-computer interface, a tiny implant that reads your brain's electrical signals and translates them into actions on a device, like moving a cursor or clicking. Imagine your brain as a stadium full of cheering fans, your neurons firing, and the implant as a super-sensitive microphone picking up those cheers. It processes about 16,384 variables 66 times a second. That's a fire hose of data. The implant filters it, sends the key spikes via Bluetooth to a computer, like a MacBook Pro, and AI models decode your intent into movement. To bring this to life, let me show you. As you can see, my Neuralink implant is a coin-sized device with 64 ultra-thin threads radiating outward, each thread dotted with electrodes totaling 1,024. More recent pioneers have received 128 threads, and I am just a bit jealous. The demo animates these threads inserting into the brain tissue by a hyper-accurate robot. I have seen a picture of my brain with the threads in it, and it looks completely clean with no bleeding. The robot is so accurate that it can see the blood vessels in the brain and avoid them. This visual shows real-time neural activity as lines of white bars spiking, like a dynamic equalizer, lighting up in patterns when I think about moving my hand. I can't see the patterns, but the computer can through machine learning and artificial intelligence. Those spikes get mapped to a cursor on screen. Early on, my cursor was a drunk mouse, stumbling around, but with training, those signals sharpened. And now, it's smooth as riding a bike. It's not magic. It's science decoding the brain's weird, wonderful ways. For us with ALS, where motor neurons fade but the brain's intent remains, this bridges the gap beautifully. Let me demonstrate how it works. I'll walk you through it because once you see it in action, you'll get why I'm so excited. First, the basics. Neuralink does not read my thoughts or deepest secrets. To be honest with you, I don't have a lot of secrets. The implant only reads my intentions to move my body, and it translates those into commands for my computer. To move the cursor, I just think about moving my left hand, the area where the implant sits. No physical movement needed. It's pure intention. We use colored targets, blue for left click, jaw clench, yellow for no click. The AI learns from that, getting smarter each time. One of my favorite features is the AI chat app, something I pitched to Neuralink a year ago, and they built it. It listens to conversations around you, uses AI like Grok to suggest responses, and speaks them in your cloned voice. Testing it with my parents was hilarious. They called it HAL 9000, and it sassed back. Now it's got my personality, witty, a bit sassy, and getting faster. And gaming? Oh man, they brought a Nintendo Switch to my house. I steer with my brain. Left and right, thoughts control the cart. I beat my son Lincoln once. Edison let me win. Abigail claims she's undefeated. But playing Mario Kart with my kids? ALS took that away. Neuralink gave it back. And travel? Before it was impossible. Now I've been to Utah twice. Fremont for Neuralink HQ, all in a shuttle bus because I'm high maintenance. Texting from the porch in the Arizona sun, editing videos on my MacBook, presenting to church groups. All possible now. Look, I know ALS sucks. It's slow, incessant, and unfair. But Neuralink has given me hope, freedom, and joy I thought were gone. I'm happier despite ALS, closer to Tiffany, literally and figuratively, and a dad who plays games again. As I shared on X, you can follow me at ALS Cyborg. I was able to watch fireworks on the 4th of July with my family in Utah. ALS had stolen that family moment. Neuralink gave it back. My outlook is brighter. I've gone from a drunk mouse to typing faster than eye gaze with fewer mistakes. It's empowered me to text outside, control devices, and dream big, like driving my wheelchair or editing videos with drag and drop. If you're living with ALS, I encourage you, sign up for Neuralink trials at Neuralink.com. Ladies and gentlemen.
All right. Thank you so much, Brad. And now I just want to introduce Jake, who can share his experiences.
Thank you, Romina. Hello, everyone. My name is Jake Schneider. I'm 35 years old, and I live in Austin, Texas. My diagnosis, I was diagnosed with ALS back in February of 22. And at the time, it's devastating. I was a 31-year-old, otherwise completely healthy male. My symptoms kind of started as a muscle fasciculation or a muscle twitch in my left arm. And I didn't really think anything of it because it really wasn't affecting my daily life. So after my diagnosis, I kind of lost that first year of my life in denial because I really didn't have symptoms. But as we all know, ALS is a disease that you can't run from, like you can't hide from it. Like eventually things started to get heavy, and I eventually lost, pretty much complete control of my arms. Can't really lift anything. My hands are now worthless. And at the time, I was a high functioning person. So to have all that taken away from me is devastating. So living in Austin, I saw P1 Nolan get the Neuralink implant. And so I just went and did my own investigation and I found the patient registry on their website. So I went ahead and signed up for that. And after that, it was pretty quick. Like the Neuralink team or the Barrow team reached out to me for a couple of interviews. And then I went to Phoenix for an in-person interview. And then we rescheduled the surgery. And I had my procedure done on June 13th of this year. And in just like the 3-ish months that I've had it so far, like it's been incredible. It's given me back so many things that, ALS taken away. Like before typing, I'd have to one finger pack, and I'd steer the mouse around with 2 hands and just it was not, a sustainable thing. And then eventually, my hands became entirely worthless. So having the Neuralink, I'm now able to participate in communication, before fumbling my phone around was not really something that I could text people back easily. Now I have iMessage, right here in front of me, and I'm connected to Neuralink pretty much every waking second that I'm awake during the day. And think one of my favorite things about being a participant is they really listen to your feedback, and take that and to make things to make everyone's life easier. And if I share my screen, um, I had helped the Neuralink team develop a typing program called 10-finger typing. And if I go here and toggle this on, I can give you guys a brief demo of what it looks like. So now I'm able to type with just my thoughts. So if I pull up just a blank document like this, I can pull this keyboard up. And if you see that this keyboard, each row has a different intended motion. So I would imagine, using these different motions to get to each of the keys. So if I try and type out very quickly something,
Jake, you have to share your screen.
oh, I thought I had click share. Link hide keyboard. Link hide keyboard. Okay, so let me go back here. And sorry about that. I thought I had shared. Okay. How about now? Can we see it now?
Yes, perfect.
Okay.
I
So
think it's the link, which is right above your top of the link.
I don't know why this is in the middle of my screen, but maybe if I go like that. Okay. I'm not really sure why this is popping up in the middle of my screen right now. But like I was saying, you can pull up just a blank document like this. And what I'm able to do with this 10-finger typing is when I pull this keyboard up, each row has a different intended motion. So all I have to do is think about making these intended motions, and the keystrokes should come out, the way that we want to. So if I imagine typing very quickly, hello, is here. All I have to do is think about this and then hit a return button, and my sentences will come out usually a lot better than that. But I was able to help them develop this program, and it's been very rewarding. So in summary, like link hide keyboard. In summary, I would say that, having the Neuralink implant has, dramatically changed my life for the better. And I encourage anyone who is in my position that is looking for answers that, the medical community cannot offer at the time. I would definitely consider the Neuralink because it's changed my life. And Romina, that's all I've got.
Thank you so much for sharing, Jake. All right, if we have Nick next.
That's me. Hi, my name is Nick Wray. I'm Neuralink's P8. I was diagnosed a month before Jake in January of 2022. my ALS started with foot drop and became concerning pretty quickly. I had been doing a really good job along with my care team, of really trying to keep out in front of what's going to happen next. With ALS, you don't know what's going to happen next, right? All of us have our own unique journey of neurons being unplugged. And so kind of trying to use fasciculations as a gauge. What am I gonna lose next? And what do we need to do to mitigate that as much as possible? Early on, are we gonna need a rollator sooner than later? When I was using a cane to walk still. It was time to get a wheelchair. Doing so when I could still walk with the cane was important. And we had done, well, we continue to do a fantastic job of staying out in front of what am I going to lose next, and what can we do to help mitigate that. And so Neuralink appealed to me for that reason. It seemed like the best way to get out ahead of a lot of things, losing my hands, losing my voice, and I lost my hands and my arms, and I lost them just in time to become a Neuralink participant. If they had been stronger, I don't think I would have qualified. So in an attempt to get out ahead of things, Neuralink appealed to me. I had not really heard of it at all. My aunt sent my dad a link from X about Brad Smith, P3, and said, hey, Brad has ALS. Nick has ALS too. And he's techie. This is tech stuff. I think Neuralink might be right up his alley. So Dad reached out, and I went ahead and put my name in the patient registry, even though at the time I thought, I'm going to go ahead and toss my email in with another, 100,000 emails of all the quadriplegics who would love to try this. And I'm very glad that I did. I recommend you do. Don't let the numbers be a deterrent, because if you're a good candidate, you're a good candidate. Excuse me, speaking is getting harder in the evenings, and it's 8:40 here. I've been working with Neuralink on the ARA, the assistive robot arm, among other things. And I have a couple of videos that I'll show you in just a minute. I have been working on that digitally, remotely with the team in Fremont, California, until a few weeks ago, when a group of those guys brought a robot arm to my house, and I got to try it out and use a real robot arm. And let me just share my screen and pull that up. Share QuickTime Player. I'm just going to do the whole thing because I don't know. Share. All right, I am screen sharing. I hope y'all can see it. So this is me. The arm sticking straight up is the robot arm, a Canova Gen 3 robot arm that I got to use. And this is me putting on a hat for the first time in 3 years. I don't know if the audio is coming through or not.
I don't hear the audio.
So that's me putting on a hat for the first time. There was not a lot of audio. That was being able to do things in the physical world is absolutely science fiction. I mean, ALS takes and takes and takes and takes and takes. And when things are gone, they're gone. That's part of coming to terms with ALS, or doing our best to come to terms with ALS, is getting used to the idea that that's a thing I'm never ever going to do again. And whether that thing is typing on a keyboard or moving a mouse, or in my case, doing graphic design or photography or drumming or audio engineering, being able to get any of those things back was a fever dream at best 2 years ago. And I might not be drumming yet, but I am able to do things in the physical world. I can do audio engineering and photography editing. And here is me using the assistive robot arm. This is day 3 of use. And at this point, I was using it with the intent to move, as opposed to the intent to up, down, forward, left. It was more gesturing, which you'll see in the clip.
You like gesture wildly with it. You're like, you guys, you know what I'm talking about, right? And here's the so I'll be able to talk with my hands again. So we're all here tonight, I think. Yeah, the arm gesticulating. I see it.
I'll be able to give a toast. Oh, and I'll let that one play because that's pretty cool too. I get to take a drink of water. I lifted my own cup to take a drink of water. And to any of the pals that are watching, yeah, I did that for the first time in however long. And it was as incredible as you would imagine it would be to do something that you have come to terms with never ever doing again. Like Romina said, it's early days, and this is all research. And being a member of the PRIME study and the Convoy study has been very, very cool. But I think it's also important to remember I signed up to determine the safety and efficacy of a robot surgeon. And for me, it was more than worth it to have the opportunity, to have the chance at getting something back. And even if I didn't, if I had woken up and my chip hadn't worked, I would have still woken up and felt useful in ways that I had not in years, because I would get to help them try and figure out why why did this one not work? And having such a profound, distinct sense of purpose for me was immense. And I woke up and it worked. So I get some pretty good benefit adds to my life. And having those things it's great to be able to use a computer, but it's even better to be excited about what I might do tomorrow. Because to me, that was the most important thing that ALS took from me, was being excited at all about the future. And that is one of the things that Neuralink was able to give me back before I even went into surgery. And it was something that it has continued to give me back since. And that's my time. Thank you.
I mean, this is just incredible. And thank you so much to everybody for sharing your experiences and really bringing this whole process and the impact to life for us. We have, not surprisingly, we have quite a few questions that have come through. So I'd love to invite our Neuralink crew to come on screen, and let's jump in. Lots of questions about how to participate. How do I participate in the trial? What are the requirements for the trial? Trials, please. So why don't we start there?
Yeah, perfect. So I did see a question also on like location, so I'll start with that as well. We have 3 study sites in the United States for Prime. We have in Arizona, the Barrow Neurological Institute. In Florida, we have the University of Miami. And then for the voice study, we have UT Southwestern in Dallas, Texas. You do not need to be local within those states to participate, and Neuralink does cover costs for travel and lodging, anything that's required in terms of traveling to and from the study sites in order to participate in study visits. So cost it's not an issue or a concern. However, travel might be depending on how far you are and what your specific unique conditions are. We've had participants who travel in vans on ground, or we've also had participants who are comfortable flying as well. So I just wanted to say that. If you want to learn more or participate in our trials, you can apply directly to our patient registry, which was on that link I showed, neuralink.com/trials. You can go to the study sites directly, and you can get their contact information from our website as well, neuralink.com/trials. Or if you're familiar with clinicaltrials.gov, we have our studies listed there and the study contacts that you can reach out to. And of course, if you have any direct questions, I'm happy to provide my email as well for anyone who wants to reach us, which is romina@neuralink.com.
And as a follow-up, and forgive me, Romina, if I missed that, are there any sites in Canada at this point? We have a couple questions about Canada.
Yes, so we do have one study site at Canada. It's the University Health Network, Toronto Western Hospital in Toronto, Ontario, and the principal investigator for that study is Dr. Andres Lozano.
Yeah, Nick, jump on in.
Thanks. I saw a couple questions in the Q&A and thought I would add my 2 cents about getting the Neuralink with ALS and with anything else, spinal cord injuries, whatever. It's not going to cure my ALS. I'm not going to get the movement back in my arms. I will be able to control a robot arm. I will be able to control my computer, but I'm not going to walk again. The ALS progression isn't going to slow down. It's just going to keep going. So it's not a cure, but it is going to make the rest of my life one heck of a ride. And like I said, I'm excited for tomorrow, which I didn't used to be. So it's not a cure, but it is one heck of a salve.
And we had a chance in the video to see a little bit of a travel demonstrated, but we do have questions about the portability of the equipment.
Yeah, so the device itself is completely wireless and portable, so you can use it anywhere. You go to the hospital study site to get it implanted, but after that, it's with you, so you can take it anywhere. You can take your laptop. So cars, planes, we've seen participants use it. Obviously, your own home, that kind of thing.
Related to that, I saw a question come through. Can you go through the metal detector at the airport?
You
with
can, you can. I'll let I don't know if, have any of you three traveled through the airport yet?
Yeah, I fly each time when I go out to Sparrow. And I just opt out because I didn't really know what was going to happen. So I opted out. So they used to do a pat down. Um, but it's good to know that you can go through it.
And I can't go through it because I am in a power wheelchair. So that would preclude you whether the implant is safe or not.
We have related questions about, sort of MRI and imaging tests. Can someone get an MRI with the Neuralink implant?
At this stage, you can't get an MRI if you have the device implanted.
Great. And, again, sort of all related, what's the maintenance involved? Is there work at home or any kind of maintenance required? We have some questions about battery life and charging. If you can speak to that, that'd be great. I heard the answer to this question. I love it. So go, you guys, take it away.
Yeah, I would say the maintenance, I mean, is obviously pretty low. The main thing is just keeping the battery charged. And it usually takes about 45 minutes to an hour to charge from 0 all the way up to 100. And that would give you 5, 6 hours of runtime, usually, depending on what sorts of applications you're running in the background. But that's typically how I would see. Nick, I don't know if you saw anything different, or Brad.
Brad has hi, I'm Tiffany. I'm Brad's wife. And sometimes it's easier if I talk. But he has a first generation Neuralink implant, and his charge lasts about 4 hours if he's using it full time. But the charger is super easy to bring with us. Let me show you what it looks like. Over here and show you. So I don't know if you can see here, but this is the charger here. It's just yes, he loves me. But here's the charger. It's super small. You just place it near the site where the implant is, and it starts to charge. And so you can slip it in a ball cap and have it charge while you're on the go, and it's super easy. Charging is super easy. So we don't worry about that. And I was going to speak a little bit to travel. We've done more travel since we've had the Neuralink than we have ever since ALS took so much away, and it makes it so much easier. It was very hard to go very far when Brad was unable to communicate because we couldn't use the eye gaze device while we were in the car. But with this, he can hook up his computer and he can communicate. We can hook up the Starlink to the van, and he can access the internet. He can, do all sorts of things. So it's made travel more doable for us. Travel is never easy with ALS, but it's
Yes.
doable with the Neuralink.
Thank you so much. That's really helpful. And then we have lots of questions about AI and if and how AI is potentially leveraged with the Neuralink.
I can start with that one. So we do use machine learning algorithms to essentially decode the neural data that's streamed from the device. In terms of integrating with third-party AI apps like ChatGPT or Grok or any of that, that is only done through explicit consent of the participant. And so Brad, I know he uses the chat app, which links to one of those large language models. And again, we never sell your data or anything like that to third parties. This is all through explicit consent. You can opt in and then integrate apps into your computer like you would onto your phone.
Perfect. And, this is an interesting question. Any side effects from the Bluetooth connection, like headache or hot spots?
No, I haven't experienced any headaches. My head doesn't get warm when it charges. You can't really feel it at
No,
all.
Brad agrees. There's nothing that he's ever
yes.
in association with that. It's actually kind of cool how they've created if they have a temperature sensor in the implant, is my understanding, because if it starts to get warm at any point, the charging will shut down until it cools off. So there's a lot of fail safes in there, is my understanding, so it doesn't get warm at all.
That's great. That's great. We have about 2 more minutes, so I'm going to lightning round these next questions. And I'm totally watching what's happening on the screen too, which is also informative for all of us. As we look at that, what is the training time? How long does it take to become proficient? Jake, I don't know if you want to. Oh, I see. There's everything I'm saying.
I'll pop on that one.
Picking out a tutorial on your tech, learning as I go.
Yeah, the learning curve, training time varies.
I would say, oh, sorry, Nick, I didn't want to.
Training time forever, apparently. I'm basically a tech wizard in training now.
I personally found the learning curve to be very, very short. I feel like I picked up the proficiency for the cursor control really after a couple hours of being hooked up to it. I mean, and then by day 2, I was on it so much that it's like I'm charging the battery a couple times a day because that's how much I was using it, because it feels like getting, your wings back, it feels like you're flying again. So like when I get the implant, all I wanted to do was learn as much as I could, as quickly as I could.
It's absolutely incredible. I mean, I know it's 9 o'clock. We're at time. We have so many questions still in the Q&A. I wonder if I can just squeeze in one last one if folks are willing to stay a couple of extra minutes. We have a lot of questions and some questions that were submitted before the webinar too about level of functionality and eligibility. And some folks are describing themselves as locked in, for example, and just wondering both now and in the future, what level of functionality is really required to participate.
Yeah, so at this moment in time, as long as you have minimal, you can be locked in to participate. You can be ventilator or trach to participate. If you haven't decided on whether mechanical ventilation or tracheostomy is for you for your future in general, that's something you would have to think about before enrolling in the study. Because there's risks with surgery, right? And so that's one aspect. And then in terms of as long as you quadriplegia, we define that very specifically through motor strength grading. For the sake of time, I'm not going to go through every one of those, but if you have minimal, I would say minimally useful functionality of your hands or arms, and you're non-ambulatory in that you can't walk, you would qualify for the PRIME study. For the voice study, you can actually stand and still have some of that lower limb functionality. It's more of an upper limb and severe speech impairment. So there's slightly different in terms of eligibility criteria there.
That's so helpful. And this has been tremendous. I've learned so much from all of you. Brad, Nick, Jake, no one can describe the experience better. And the three of you did a really terrific job orienting all of us and helping us understand what that's like. So just thank you everyone so much for joining us today. I'm sorry that we weren't able to get to all of your questions, but hopefully we covered the big themes and topics that emerged today. And we are grateful to each of you for being a part of our community. And once again, a big thanks to all of our sponsors for their support. Of course, they make this possible. And the ALS Network brings our community together in various ways throughout the year to create help and hope for families impacted by ALS today, and also for those who will be diagnosed in the future. And these often celebratory and always meaningful gatherings provide opportunities for connection and raise awareness, and of course, raise funds to benefit ALS Network's mission priorities. So please visit events.alsnetwork.org to learn how you can join us at one of these events. And our ALS United attendees from across the nation, you can go to alsunited.org to find events in your local region. And of course, as you already know, philanthropy fuels everything we do, and we are so grateful for those very generous donors who make gifts of all sizes throughout the year. And to learn more about how you too can support valuable programs like this one today, please visit our website at give.alsnetwork.org. Please watch for the short survey on today's presentation that you'll receive via email in order to help us plan for future educational programming. That's for our viewers on Zoom today. Thank you again so much. We will see you next time, and we will make this recording available on our website if you want to share it and or view it again. It will also be on our YouTube channel. Have a wonderful rest of the day. Thank you again.
Thank you, Sheri.